Good morning, everyone. We are here to present our topic Architecture of UML under the subject Object Oriented Analysis and Design. The subject code is 23CSC 504. The architecture of UML. UML, which stands for Unified Modeling Language, is a standard method used to visualize, design, and document software systems. It helps in understanding both the structure and behavior of a system through different types of diagrams and models. This presentation is prepared and presented by our group members, that is me, S.N. Mushkina Banu, Y. Bhavana, B. Sri Vijaya, Y. Vasundhara, M. Tejashwini, and at last S. Sri Lakshmi. Coming to the slide, Architecture of UML. UML stands for Unified Modeling Language. UML is a visual language used to model, design, and document software systems. The architecture of UML is based on the 4 plus 1 view model. The 4 plus 1 view model is introduced by Philip Crutchton. This model divides the system into 5 interrelated views that together give a complete picture of the system, which provides a comprehensive framework to describe a system from multiple perspectives, ensuring all stakeholders' concerns are addressed. The view models are use case view, design view, process view, implementation view, and at last deployment view. Coming to the next slide, this slide explains the architecture of a software intensive system. Can best be described by 5 interlocking views. Each view is a projection into the organization and structure of the system, focused on a particular aspect of that system. It means using the 5 view model proposed by Philip Crutchton in the 4 plus 1 view architecture model. The architecture of a complex software system can't be understood from just one angle. So we can describe it using 5 interlocking views, each focusing on a different aspect of the system. The first one is use case view. This is the core view that connects all other views. It shows how the system is used by external actors as users or other systems. It helps capture functional requirements and use cases. The second one is design view. It focuses on the logical structure of the system, deals with classes, interfaces, and their relationships like vocabulary and functionality, used mainly by developers and designers to understand the software internal organization. The third one is process view, describes the dynamic behavior of the system, shows how components interact at routine handling, performance, scalability, and throughput, important for ensuring the system runs efficiently. The fourth one is implementation view. It focuses on software organization in code, like the actual implementation, deals with modules, packages, configuration, management, and system assembly, used by programmers for managing and maintaining the system code. The last one is deployment view. It describes how the system is physically deployed on hardware. It means the system is physically deployed on hardware. Shows system topology distribution, delivery, and installation. Used by system engineers and network managers. So, I can explain the overview of 5 views. So, our group members will explain the all 5 views in clear detail.
Good evening, ma'am. This is Bhavna from CSC section. Here I am explaining about use case view. First of all, what is use case? The diagram is showing how external entity is called as actor. It interact with the system, achieve a specific goals, defining the system, functional requirements, and overall the behavior. Here the definition of use case view. Use case view represent the functional requirement of a system from the end user's perspective. That means the use case view show what a system must do for its users. It describes the functions that the system performs in response to action by actors. The word functional requirement means expected services or behavior of the system. It focuses on what the system should do, capturing interaction between end users and the system through use case. That means the interaction between actor and system is shown as a line connecting them. For example, hey human users customer and admin and the payment gateway. The weave helps in understanding the system behavior of the system without going into implementation details. That means it helps you understanding that the system does at high levels. You don't need to know code or technical details. It visual code and simple way for both developers and non-technical stakeholders to understanding the system. For example, before developers write the code, they can show the diagrams to users and confirm. It serves as a foundation for designing, developing, and testing of the system. Uh, that means designing it helps the software architecture design system components to support each use case. The development is a developer to write the code, then we implement each use case. Testing to test to verify whether each use case works or as expected. So use case guide the entire software life cycle. Here the use case view diagram. Actors represent to user or external system. It is initial of the interaction. For example, student, customer or admin. The use case view to represent the functions the actors want to perform. Here the function is view means view the data, view report or view details. The association line is the straight line connect the actors and the use case. It show interactions. It means actors use these functions in the system. And how to read the diagram. The actors interact with the system to perform the actor view. That means the user initiate the request. The system provide the functions or response. This is the simplest possible for use case relationship. Here the plant UML diagram and code. The customer is the actor. The actor it will perform how to interact with the system. The actor to represent who uses a system. Here the a customer perform all the main operation of the shopping system. The customer is interact with such product, add to cart, placeholder, make a payment. The system is perform the rectangle label system to represent the boundary of the online shopping applications. Everything inside the box is what the system does. Everything outside is external. The use cases are such product, add to cart, place order, make a payment. Such product the customers can search for available products in the system. Example browser, add to cart. After selecting the items, the customers add them to the shopping cart for purchase. For example, online shopping, the placeholder, the customers confirm and place the order for items in the cart. After confirm the place and to make a payment, the customers to pay for the order using online payment options. That means the customers directly interact with each of the system functions. The purpose of the diagram to show how the customers uses the online shopping system to represent the functional requirements from the user's point of the view. to help developers understanding what services the system must to provide. Here the plant UML diagram. The actor customer is to represent the users who interact with the system. Uh, interact with the system. The rectangle system defines the system boundary. Everything inside belongs to the system. The use case is use defines individual use case. The customer it show the association interact association means interact between the actor and the use case.
Good evening everyone. Today I will be presenting on the design view, one of the key perspectives in the architecture of an UML based on the view model. What is design view? Design view, also called as a logical view, focuses on the internal structure of a software system. It shows how the system is built, what classes, objects and components make up the system, and how they interact with each other. In the use case view shows what the system should do. In the design view shows how it actually does it. Think of it like a building plan. The use case is list of rooms and functions, while the design view is the wiring, public and structure behind the rooms. The design view, also called as a logical view, shows in the internal structure of a system what is made up of classes, components and services, how those parts connect and interact, and how they organize logically and fulfill the behavior described in the use case view. Purpose of a design view. The main goal of the design views are to represent the logical structure of a system, to define the relationships between classes and components, to serve as a blueprint for developers during system implementation. Think of it as a structural architectural blueprint. Our system, like a building plan, shows rooms, public and wiring, not just what the user sees. It helps in ensuring that every functionality described in the use case view is properly supported by classes and methods. This is the diagram of the design view. Planned UML diagram. This code is based on the given diagram. This is from the planned UML. Diagram explanation. Let us understand this diagram step by step. User case represents a general user in a system. It has attributes like user ID and name, and operators like login and logout. Account classes linked to the user class. It holds account related data such as account ID and balance, with methods to deposit and withdraw money. The association user account shows that a user owns or operates an account. Admin class inherits from the user class. Admin manages, and admin is also a user but with additional privileges like manager uses. This diagram helps visualize object-oriented design principles like encapsulation, inheritance, association. Encapsulation means using private attributes and public methods. Inheritance means admin inherits from user. Association, user connected with account. Let us take a real life example. For example, imagine an online banking system. A user logs into their account. They can deposit and withdraw funds. An admin can oversee user activities and manage accounts. This logic design helps developers later build the actual system structure in code. Summary of a design view. To summarize the design view is the blueprint of the system's internal structure. It uses class diagrams to show relations between objects. It ensures that design supports the use cases effectively. It acts as a bridge between the requirements and the implementation. Thank you.
Good evening, ma'am. Today I'm here about to explain about the process view. The process view that represents the dynamic behavior of a simple web-based system. We will walk simple web-based system. We will walk through a diagram that shows how different components of the system interact during integration, especially focusing on how they communicate and handle requests in real time. Going to the overview of process view, the process view in UML is used to capture the runtime behavior of a system. Particularly, how it behaves under concurrent operation. This includes how multiple sets or processes work together, how communication flows between the components, and how data is managed throughout the system. Going to the explaining the components of the diagram of the system, the client node, this represents the user side, typically a web browser. This is the user initiates an action, for example, logging in or requesting data by sending an HTTP request to the server. The second component, the server node. The server receives this request and identifies the users or session using something like an account ID. It acts as a bridge between the client and the deeper parts of the backend. And third is the application server. This is where the business logic lives. All the core processing of data, decision making, authentication, and so on happens here. Think of this as the brain of your application. And the fourth component is the database server. Finally, we have the database server, which stores all the data. It's managed by a DBMS or a database management system. The application server queries or updates this database based on the request from the client. So the complete flow is the client node uh, goes to server node and the server node goes to application server and application server goes to database server and then the response goes back up in the same order. The means it can also go and it can respond in the reverse order. So means the real-time behavior. What makes this a process is that it shows what happens at runtime, not just structure. When a multiple clients send requests at the same time, the server might spawn multiple threads or processes to handle them concurrently. Each request goes through the same path but independently, ensuring the scalability and responsiveness. This model helps us to understand performance, bottlenecks, and concurrency issues. For example, if database gets too many concurrent requests, it could not become a bottleneck. Going to the UML code. The code snippet have uses a plant UML, a simple tool to create the UML diagrams using text. Here the start UML, the client node goes to server node and the server node requesting the server node requesting here the client node requesting the server node and the server node goes to application server and the application server goes to database server. It defines the basic sequence of the communication between four components. The arrow shows the flow of messages or requests. This is a minimal but powerful representation of the process flow in a distributed system. Means this means when the multiple clients send requests at the same time, the server might spawn multiple threads or processes to handle them concurrently. In each request goes through the same path but independently ensuring the scalability and responsiveness. In conclusion, the process view in UML helps us to visualize how different components of a system interact during execution, especially useful when dealing with concurrent tasks or a distributed architecture. Thanks for giving this topic to explain about the deployment of the view, logical view, or any other UML perspective in the in the architecture of the UML.
Good evening, ma'am. I'm Sri Lakshmi from CSC. See, today my friends already explained that use case view, design view, process view, implementation view, and my topic is deployment view. Firstly, what is UML? UML is a standardized visual modeling language used to specify, visualize, construct, and document and software and non-software systems. In this deployment view is a type of architecture view that describe how software deployed on hardware infrastructures. It mainly focuses on runtime environment, including servers, devices, networks, and how components, example like services, databases, and applications are distributed and interact across these resources. In deployment view is how software systems are physically deployed on hardware infrastructure, and it includes servers, devices, and networks, and are distributed interact and it deployment view are distributed and interact across these resources. Let me take an example. ATM Mission. ATM Mission deploys the ATM application, and the and bank server request or response from ATM application it deploys, and this includes transaction manager. Transaction manager manages the money and draw money in the ATM machine, and it is also include that in this in this example database server also included that SQL side query DBMS artifact. In this totally diagram we can see the how ATM mission performs and the user performs actions in the ATM mission. Here we see the code of UML diagram. It will start at the start at the data start UML. In this define nodes ATM mission as ATM act as ATM artifact and ATM application. In this node bank servers as bank artifact transaction manager. The transaction manager also called as bank servers. Bank server maintains the money how many in one day how many money want to deposit. In database server database will be included like inserting the amount debited the amount from the ATM machine, and this also some DBMS concepts will be included, and the user want to take the draw the money from the ATM machine. The several steps follow the user. The connections in this ATM missions while drawing the amount from the ATM machine. ATM to bank. ATM requests the amount from the bank. Banker deposit the money in the ATM machine. Bank DB SQL query at the data end UML. In
Good evening, ma'am. Let us see the implementation view. The implementation view refers how the system software is physically organized in terms of components and their relationships. That means the software system is physically organized into components. That components are interacted with the user interface. It's primarily concerned with the realization of the system in code and runtime infrastructure. It mainly focuses on the realization of the system. It deals with the code structure and infrastructure. It's important for developers and architects to understand the actual deployment and system composition. Let us take the example that is ATM mission. ATM UI. The UI abbreviation is the user interface. ATM user interface interacts with ATM controller. ATM controller uses transaction manager. Transaction manager calls account service. Transaction manager calls authentication service. Transaction manager queries with the DBMS, that is database management system. DBMS again break down into the account data and user data. Let us explain about deeply this example. ATM user interface interacts with the ATM controller. ATM controller controls the flow of information from the user interface. Transaction manager calls account service to handle the account operations. Transaction manager calls authentication service to handle the authentication related operations. Transaction manager queries with the database management system to handle the data and information. DBMS again break down into account data, user data. In account data, it stores the account related operations. In user data, it stores the user related operations or data. For the above example, this is the code. We are taking a tool that is plant.uml. We are running this code in the plant.uml. Let us deep out into the code. @*uml. ATM user face interacts with the ATM controller. ATM controller uses the transaction manager to handle operations. Transaction manager communicates with the account service to handle the account related operations. Transaction manager communicate with the authentication service to handle the identity service. Transaction manager queries with the DBMS to check out the errors. DBMS handle the account data. In account data, it stores the account related operations. DBMS calls user data. In user data, it stores the user related operations. @UML. We are running this code in the plant.uml. After running the code in plant.uml, the diagram it is ATM UI interacts with ATM controller. ATM controller uses the transaction manager. Transaction manager calls account service and authentication service. Transaction manager queries with the DBMS. DBMS again break down into the account data and the user data. In final, let us see conclusion and summary. The architecture of UML helps in designing and understanding software systems clearly. It shows both the structure and behavior of a system through different layers and models. UML makes software design simple, well organized, and easy to share among developers and designers. Overall, it provides a clear and standard way to model systems and improve communication in software development. Thanks for giving this opportunity.